Good morning, everyone. My name is Yash. I work for Aruba as technical marketing engineer. Today, I'm going to cover port access concurrent onboarding feature, which is getting introduced as part of AOS-CX 10.06 release. As part of this feature, we are going to cover the above agenda, as you see on the screen. Overview, use cases, details, and caveats, which will have a packet captures of in detail as much as possible. And we'll have a configuration. How do you configure this feature? And also we'll provide the best configuration and practices as part of this presentation. Along with this, we'll have a troubleshooting and followed by a demo. Demo will contain the complete feature demo of this concurrent onboarding, which is also recognized as parallel authentication, and which we'll also provide additional resources. Let's get started with the overview of the concurrent onboarding. Concurrent onboarding is getting introduced as part of the AOS-CX 10.06 release. As name itself suggests, it is going to onboard the clients as fast as possible. So concurrent onboarding is a process of getting the clients faster and avoid the wait time of any other auth methods. So as you see on the screen, the .1x client, when it connects on a AOS-CX switch, because of the auth precedence, it will take same time whether you enable client concurrent onboarding or not. But if you have a client like Mac client, which is connected to AOS-CX switch, because of the auth precedence, first, even though it's a Mac auth client, the first auth precedence will attempt for a .1x. Once upon the .1x expiry, the Mac auth will be triggered. Means the Mac auth client needs to wait. If it is with the default ePAL timers, then it needs to wait for 162 seconds to get its chance to get authenticated. It means every Mac auth client which is connected on AOS-CX switches with both the authentication mechanisms turned on the port, it needs to wait for worst case. If the ePAL timers are not tuned, then it has to wait for 162 seconds. Where in case of concurrent onboarding, which is getting introduced 10.6 and later, all the auth methods will be triggered concurrently. With that, either it is a .1x or Mac auth, both authentication or requests are going to be triggered at same time parallelly. Hence, we'll achieve faster onboarding of clients. Consider another case where you have a PC behind a phone. The phone is a older phone, which is not a EAP capable phone. It is a Mac auth client, and you have a PC. The PC, as soon as it reaches the AOS-CX switch, it will get onboarded, where in case of the phone, it takes a longer time to get onboarded. Because the phone is not getting authenticated, the port, which is 2/ whatever the port you are connected, will not be open for communication. Hence, concurrent onboarding brings and solves this problem of delay in onboarding and brings faster onboarding of the clients. Let's see the use cases. As we discussed, one use case is the Mac auth client which are connected like printer are going to be having lesser time to onboard. That means it takes exactly same time the access request will be sent to the ClearPass. EAP, as you know, .1x is going to take a little bit longer compared to a Mac auth. Mac auth will get attempted as soon as the Mac learning happens on the port. Let's consider 3/1/1 learns the printer Mac. As soon as it learns, it sends that request to the Radius server and gets the access accept if it is a valid client, and the port will be unblocked for this client. Where in case of the .1x client, it will send the access request as soon as the EAP request comes from the reaches the AOS-CX switch with the EAP response. It reaches once it reaches the EAP response, reaches the AOS-CX switch, it will form the Radius request packet and access request packet and send it to the Radius server. Radius server will again send back the challenge, and that challenge has to be need a response from the client, and the client will respond. If it is a valid client with the right challenge, it will get access and onboarded. The process of .1x and MAC auths is authentication mechanisms are different, but both the auth methods will be triggered at the same time, and that access request will be sent from AOS EX switch to the Radius server or the ClearPass. That's how, whether it is a MAC auth client or any other client which is connected on that port, all that authentication mechanisms will be triggered concurrently so that it will be a faster onboarding process. That's a one use case where you have a MAC auth client which is delaying you. Then if you can connect you can enable the concurrent onboarding on that port. The second use case is the Pixie client. The Pixie clients, as they boot, it comes up with a MAC authentication, and once the MAC auth is authenticated, it downloads the Pixie client will download the supplicant .1x supplicant onto the Pixie client. So this process, if we are not enabled the concurrent onboarding, the Pixie client cannot be onboarded quickly because the MAC auth has to wait. So in those cases, the best feature to enable on those ports is the concurrent onboarding. With that, what happens is the Pixie client can get onboarded faster. It can download the EAP supplicant and attempt the .1x authentication for the same client. So this is how both the use cases can be met with the concurrent onboarding as part of the 10.6 image. Let's see the details and the caveats as part of this concurrent onboarding. Port access onboarding method concurrent enables all authentication methods to start concurrently for faster onboarding of the clients. Default priority for concurrent onboarding is .1x followed by MAC auth and then the device profile. When the authentication method with the highest priority, let us consider if it fails, the profile of the next successful authentication method will be applied. Means if the first preferred method for that client is always .1x, if the default priority is not changed, always .1x. If that .1x profile fails, then for the same client, it will apply the MAC auth profile. Okay. The one thing you have to notice, as soon as you enable the concurrent authentication on that port, all the clients will get de-authenticated, and because we configured the concurrent authentication, all clients' auth requests will start concurrently and get onboarded on the same port. The another thing which you have to note is, if you have configured the pre-auth role on that port, all the clients during the process of the concurrent onboarding will use that pre-auth role. For example, if you are onboarding .1x clients, the .1x client, because of the .1x mechanism, will take a longer process to onboard, which I'm going to explain why it is going to take a longer process of the .1x process. We'll see in a minute. In that time, what it can do is the clients can stay in pre-auth role. If they succeed, they will get into appropriate roles. Otherwise, if they get failed, if the client is not succeeded, it will be moved to a failed state instead of a pre-auth role. The one thing you have to note, whether it is reject or a critical role when it gets applied to the client will continue to re-authenticate using the .1x request. If all the methods fails, that means if the MAC auth also fails, first it will attempt a .1x, that also fails for some reason. If the same client will authenticate, you try to authenticate using the MAC auth. If that also fails, whatever the reauth period you have configured or with the default reauth period, even though client is in the reject role or in the critical role, will keep trying and keep the re-authentication using the .1x method. This is not a limitation, but sometime during the deployment, we see for few clients, that means any client which is getting onboarded, the Radius server will only accept one type of auth method. That means it will allow for one client. If it is a PC, it will allow only .1x. If it is a MAC auth client, it will only allow MAC auth. In such situation, the concurrent onboarding will not help because this will send both the authentication requests to the Radius server for each client. So in case if you have a Radius server blocking the auth request and it will allow only one authentication request per client, in that cases, you have to move to auth priority, which will be covered, which is also getting introduced as part of 10.6 release and will be covered in the subsequent TOI. So as I was talking about concurrent onboarding and the pre-auth role for a .1x client, mechanism itself takes longer time. Let's look at that one. When we have a client with a .1x and a MAC auth, which is connected on a port, what are the mechanisms happens as soon as it hit the AOS-CX switches? As you see here, the highlighted one is the command which you are going to enable on a port where you are connected the clients. Port access onboarding method concurrent enable. As soon as you enable this command, the clients which are connected, consider this phone and the PC will be de-authenticated, and these two clients will get re-authenticated or will be freshly onboarded concurrently. What does it mean is EAP request will reach the AOS-CX switch, and also the MAC auth request will reach the AOS-CX port. Both access requests will be sent to the ClearPass concurrently by this AOS-CX switch from 10.6 onwards. When it gets the EAP identity from the AOS-CX asks for a EAP identity of a client, and clients responds back with the EAP identity. Once it gets the EAP identity, it will formulate the access request and send it to Radius server. The Radius server will challenge back and send that to a AOS-CX switch. Then the AOS-CX switch will formulate that one and send that EAP request back to the client with the same challenge. Once it receives the challenge response, then again another access request will be sent to the ClearPass to get the access accept. If it is a valid client with the right challenge, it will get the access accept. Once it gets the access accept, the EAP success will be sent to the client and client can communicate from there on. The port will be open. Where in case of a MAC auth client, as soon as the MAC learning happens on that port, because we have enabled the authentication MAC auth on that port, the access request will reach the ClearPass. If it is a valid MAC, it will get the access accept. The mechanism for a MAC auth is, though it is simple, but it's not highly recommended. It is not a secure mechanism, but EAP is a highly secure mechanism. That is, .1x authentication is highly secure when in case of a MAC auth. But we have to think about MAC auth due to deployment of older devices on the network, right? So this gives you a complete packet capture of .1x heap authentication, how it happens between a client authenticator and authentication server. So the client is nothing but a supplicant. The supplicant sends out the identity once the authenticator asks for an identity. So the client will respond back with the identity details, and that identity details will be carried to the respective Radius server or the ClearPass. So once it knows the identity, it gives a challenge back to the client asking further what kind of authentication mechanism it is using, whether it is MD5, TTLS. Depending on that, this challenge will be sent back to the AOS-CX switch, and the same challenge will be forwarded as a EAP request back to the client, and client will respond back with that challenge. And then if the challenge differs at the client level, let us consider you have a TTL and you're configured on the Radius server, the priorities are you're configured as the first as MD5 and then the PEEP. So it will take another one more retry to get the same challenge. And once it accepts the challenge, same will be sent as access request back to the Radius server, and Radius server will respond back with access accept if it is all valid. Then once it has the EAP success in that access accept, the AOS-CX switch, which is authenticator, gives a EAP success back to the client, and the client will get onboarded automatically. You can see all of the details in these slides. You can see here, this is the last if success message will be sent to the client once it receives the access accept from the ClearPass or from the Radius server. In case of a MAC auth, as we are talking about, as soon as the MAC learning happens on that port and the port is enabled with the MAC authentication, then the access request will be sent to the respective Radius server or the ClearPass. And if the MAC is valid, it will be given with the access accept and respective role for that, that client. So how do you enable the concurrent onboarding on the AOS EX switches? It is very simple. So you are getting into the config mode interface of the whatever this where you have to enable this. Before enabling, please note down that as soon as you enable, all clients which are enabled authenticated on this port will be de-authenticated and they will be freshly onboarded concurrently. Okay, and if you have enabled auth precedence in the previous release, please make a note, it will be ignored automatically as soon as you enable concurrent authentication on this port. This concurrent onboarding or parallel authentication is supported on 62, 63, 64, and also on simulator, AOS EX simulator. The best practices on this in 10.5, we recommended the following configuration on the port as the best practice, where in case of if you want to use the concurrent onboarding and you know that the Radius server will not block more than one request, access request reaching the Radius server, then you can enable concurrent authentication on those port where you want to enable the, you know that those ports, some of the ports have a MAC auth client, or you want to onboard many clients are there, all clients have to be onboarded together, then this is the best feature to enable on that port. Rest all configuration remains same. If you have a AOS switch and trying to convert the AOS EX switch configuration to AOS CX, this is the way you are going to convert. The AOS EX switch configurations are here and the AOS CX configuration on the right hand side. So with this, let's see the demo. So the first demo, what we are going to do is, let's have the two clients, which is an old phone. As you see here, this is an old phone and which will do a MAC authentication. And here I have another printer which will also do a MAC authentication. We have two clients. What we will do is one of the port will enable the concurrent onboarding and another port will leave it as it is as 10.5 image. That means this port will have without the concurrent onboarding feature configured, where this port will have concurrent onboarding feature enabled. Both are the MAC auth clients. The expectation is this client where we are not going to enable the concurrent onboarding should take 162 seconds without any ePOL timers. As you see here, these ePOL timers are not, I'm not going to configure on the device to show you how the MAC auth client will be delayed without enabling the concurrent onboarding. Where in case of the other clients where you see the MAC auth client, this client will be onboarded as sooner as possible. As soon as the MAC is learned, it will not attempt the .1x authentication for this client. Instead, it will directly, because both the auth methods will be triggered simultaneously. So this client will be onboarded as soon as possible. So after this demo, this is the demo 1. And we'll also see another demo where PC behind the phone, both these clients will be onboarded as quick as possible with concurrent onboarding, or also this is recognized as parallel authentication. Let us see both the demos now. So as you see here, I have the same switch on two windows. You can see it is the same switch which I have logged in, SSH login. So, and I have a ClearPass which is on the below. So show port access client. Before that one, let us check the configuration on this port 2/1/1. This is no shut and it is connected with the printer and it is enabled with the concurrent authentication is enabled. The command for enabling this one is, you are going to get into an interface whichever the interface you want to enable this concurrent onboarding, port access onboarding method, if you give, you will get auth precedence as the commands in the previous releases. Now with the 10.6, you will see a concurrent onboarding feature. For this, you have enable and disable. So I have enabled it on this port. So that's what you see on the 2/1/1. We have enabled the concurrent onboarding feature. Let's see on the other end, which I was talking about, another port, which is on the same switch, 3/1/1. We have a phone there, and this phone, I have not enabled the concurrent onboarding. So, but both the authentication methods are enabled on this port. So what we will do is we'll go ahead and do a port flap and then try to see which client will be getting onboarded sooner. 2/1/1, 3/1/1. So let's flap both the interfaces. Let's shut both the interfaces. So that means client will be removed from this interface. So let's unshut this. Let's do an unshut on this one because we are not enabled the concurrent onboarding. So let's give that advantage and do an unshut here. So let us issue show port access client. As you see here, it's already onboarded and it is success. The same MAC auth client, you can see here it has reached 43.7F. It reached the clear pass, and clear pass is able to give the same role. You can see here the client which is connected on 3/1/1 is still not onboarded because it is attempting, as you can see here, show port access detail command. You can see here it is attempting this one was .1x authenticated and MAC auth was authenticated because this is a 7F 437F, which is a concurrent auth enabled port. Where in case of 3/1/1, you can see it is in the default timers. .1x is still authenticating and MAC auth is not attempted at all because we have not enabled the concurrent authentication on this port. You can clearly see the port is 3/1/1. We have not enabled the concurrent authentication. Where in case of 2/1/1, we did enable the concurrent authentication. Hence, you can see it is a DUR and role got assigned for the same MAC auth client. It attempted the .1x and also the MAC auth at the same time. Where in case of 3/1/1, it is trying the .1x and it has not even started the MAC auth. This is the problem of not having the concurrent authentication or the parallel authentication enabled on that port 3/1/1. Let's check the logging into the clear pass. Let's log into the clear pass now. You can see still it is continuity. As I told you, if you are not change the .1x timers, the default in the worst case, the client is going to take 162 seconds to get onboarded because the .1x has to expire. As you see here, even now, the show port access detail command will tell you 3/1/1 where we have not enabled the concurrent authentication is still authenticating using the .1x because it is thinking it is a .1x client. Where in case of the 2/1/1, it has already come for a re-authentication, and you can see it is second time it got re-authenticated and DUR got assigned. That means downloadable user role got assigned to the client, which is 437F. Now, because it expired, .1x timers expired, now we can see the next phone reach the clear pass with access request, and you can see now .1x will be expired and now it will be trying the MAC auth. Look at this one. You can see here .1x was unauthenticated. It was trying the .1x and MAC auth is authenticated. Where in case of concurrent onboarding, watch this one. It is saying .1x is still authenticating because, as we discussed, concurrent authentication, the default auth precedence is .1x followed by a MAC auth. Even this client is still trying for a .1x authentication. Because .1 authentication is failed, it got the MAC auth authenticated parallelly, right? Let's consider the same client gets the supplicant and gets authenticated, they can get authenticated using the .1x. That time the highest priority will be automatically taken and the MAC auth will be ignored. But currently, this client is only MAC authenticated and it will continue to stay as a MAC authenticated, right? Remember, it is still trying to attempt the .1x. In case anytime this MAC auth client gets the supplicant and is capable of sending the EAP request back to the AOS-CX switch, then there is high chances for that to get authenticated using the .1x and get applied with the .1x profile. And the same client will be onboarded with the .1x. Okay, so this completes the demo 1 part. As we discussed, the demo 2 part is basically we'll have, let's go and let's for our understanding, I'm just bringing these clients down so that we understand the next one, which is a PC behind case. So I have another PC behind phone case which is connected on a port 2/1/3. Let me show you 2/1/3 by unshutting this port and bring those clients. As you see here now, there is no concurrent authentication enabled on this port. Let us watch and see how much time the clients will take to come up on this PC behind phone case. Show port access, now it is enabled. You can see the .1x, as we saw in the first slide, will, as soon as it reaches the AOS-CX switch, whether you have enabled the concurrent authentication or not, the .1x client onboarding will be same. Where in case of the MAC auth, you can see it will be in progress. You can see this is a DB42, which is a phone, the old phone. The newer phones have capability to send a EAP, but this is the old phone, and it is having a capability to only have send the MAC authentication request. But it is not getting authenticated because, as we saw in the earlier demo, this client is also attempting for a .1x. Let us see that one in the detail command. DB42 is the we are interested. As you see here, the DB42 client, though it is a MAC auth client, it is attempting the .1x. Where in case of the client which got authenticated using the .1x, because there was no concurrent authentication, as the auth precedence is there default, .1x has the same client has come in and it got authenticated, but the MAC auth is getting delayed because it is attempting the .1x. As you see here, this is the client which we saw HPN, which is getting for a re-authentication. You can see here. You can see here, this is the client coming from a NAS, which is nothing but authenticator 15.136.40.241, which is nothing but this client, and it is sending the EAP MD5, and it is reaching from and got a downloadable role in case of an earlier case, but here it is getting a LUR, which is a local user role, which is called .1x. Let us see which is the role which is getting for that. It is getting the .1x client role. Let us check whether that client role is there on the switch. You can clearly see the same name exists on the AOS-CX switch, and the same role got applied. You can see VLAN access 10 is there. Let us check the VLAN access 10 is got applied to AOS-CX or not, to the client. You can see it is the same VLAN 10 is applied to the client. Now let us check the MAC auth client has come in or not. Still it is going on. So to tune this, or let's move to a next part of the demo, which is let us enable the same port with the concurrent authentication and check how fast will be authenticated both the clients. Instead of keeping this MAC auth as so delayed PC behind the case, let us check this one. Let us enable the concurrent authentication on this interface where we have a PC behind the phone. The command to enable is very simple. Port access onboarding method, you have concurrent authentication enabled, right? So we have enabled, and let us flap this interface so that we learn the clients quicker, so that the phone will respond with some packet. Yes, please. See, okay. Still none of the clients reach this port. Hopefully I have done an unshut of this port. Let us check that one once. Yes, it is unshut, and we have enabled the, you can see here, we have enabled the concurrent authentication. You can see because we enabled the concurrent authentication, the .1x took the same time and the phone also took the same time to get onboarded on the port. This proves concurrent onboarding helps to get the clients onboarded faster. You can see on the clear pass, you can see DB42 as well as the .1x has reached at almost at the same time, where in case of we never saw DB42 reaching the AOS EX switch before during the demo, right? Only we got the .1x. Here now we can see DB42 also reached, and also .1x also reached the clear pass. With this, it completes both the demos. Demo 1, we saw a MacAuth client on a 2 ports, where one client was having, one of the port is not having the concurrent authentication, which was getting delayed, and another port we enabled the concurrent authentication, we achieved the faster onboarding. Another demo, what we did, we connected a phone and a PC. You can think of that PC as a Pixie client, and that Pixie client is also trying to authenticate using the MacAuth. That means it has to wait for a longer time. That means that same Pixie client can get expired. In those cases, enabling the concurrent authentication on that port helps them, because authentication mechanisms, both auth methods will be triggered at the same time, and the client can be onboarded faster. Let's move back to the presentation. So we saw both the demos, and this is the configuration. The troubleshooting wise, we have different ways we can troubleshoot this. You can have a mirroring enabled on the port. That means the where you are learning and also where the radius request is reaching the radius server. Both the port have them as a source interfaces, and you can do a destination interface or CPU. Again, remember, source can be a VLAN, and destination also we support with a tunnel. So destination, we have a CPU. It is also supported with the interface, and we have supported with the tunnel. So in case if you want to debug the feature at the AOS-CX level, the commands you have to use is show MAC address table detail, where you will understand whether the command will help you to know whether MAC address learned on the AOS-CX switch. LLDP neighbors and CDP neighbors will provide the clients getting learned on that AOS-CX or not. The radius server detail is very important command to know whether the radius server reachable or not. Once you have the MAC address learned and you know the LLDP neighbors and CDP neighbors command, you know the details, things are fine on the access side. On the radius server side, because authenticator and authentication server, the reachability should be perfect. So that you can get to know by using the command show radius server detail. So you can have a fast tracking enabled, that means radius server tracking enabled on the box, so that you have a reachability check, the keep alive between the radius server and the AOS-CX, which will be detected. There is a command to check the detailed status of the command, as you are seeing on the demo, show port access client detail command, which will provide the authentication requests which are reaching. That means what type of authentication is getting triggered, and also it will provide what kind of profile is getting applied. In case of failures, it will also provide the reasons for the failures. These commands are helpful. So if you want to enable and see the events which are happening with the port access D or with the radius, there is a good command for the show events -R -D port access D. This is the daemon which is running on the AOS-CX for the port access feature. So as soon as you issue that one, you will get to know what is happening on the box. So there are some DAG-dump commands which are given here. It is good to use this DAG-dump command to make sure what you configured is it really envisioned on the box. The good debug commands for this one is both port access all as well as radius all are the two debugs which you have to enable, so that you know what is happening with the E process if you are enabled with the .1x, or if it is only MacAuth, you will know whether the access request is reaching the radius server, all the attributes are reaching in the AV pair, required AV pairs are reaching the radius server. All of the details you will get to know with the debug command. Remember this debug command, which is a small mistake here, the no space when you are entering the debug port access, no space, port access complete and all. there is a destination buffer, or you can also see it from the console. Regarding the mirroring, I was telling CPU, when you enable on the especially mirror to a CPU, kindly capture that one and copy that file using your whatever the port you have a reachability to your management station, TFTP server, but make sure you disable that one as soon as you complete the mirroring of, especially when you have a destination CPU, because CPU will be punted with so many packets. So please make sure you disable that one as soon as you capture the packet. Where in case of, if you want to do a destination to another port, yes, even this one also, it's recommended to disable after the use. But if you want to keep it, you can keep it. It should be okay. Where in case of the destination CPU is something which is highly recommended to disable as soon as you are done. As I was telling, the source can be a VLAN is supported and destination CPU interface tunnels are supported. In case if you're looking to capture something on the ClearPass, some of the attributes are sent from the switch, but it is not reaching the ClearPass. So what are you going to do? You can capture that on the ClearPass itself, getting into administrator server configuration. You can name the file and capture this, start viewing it on the packet capture. These are some of the shell commands. If you're interested to see the fast logs of the port access D, that means all the attributes are really reaching the ClearPass. You get to know when you get into a problem, you want to troubleshoot. These are commands comes to handy because some of the attributes which you are sending may not be reaching the ClearPass, and you did a capture. Still, you want to know what's happening on the AOS-CX switch. This app TCL command, app CTL command will help you to get to know the fast log. Okay. With that, some of the additional resources we have, these are all published guides, and most of the details are covered. What I spoke till now, this is 10.6 security guide. You have a HTML link as well as the PDF link as you see on the screen. Two links are same below, so please ignore the last link. The first two links are the right ones. One is a PDF link, another one is a HTML link. Thank you for listening. Have a wonderful day.